Welcome back, Night Owls. This is Dr. Nighttime, and we are progressing through the written answer questions to this past fall's LTAM exam. Right now, this is question 5, the big 11-point question on this discrete whole life insurance policy. And this question isn't particularly hard, but it's asking you to essentially rederive the formula for variance of a variance of present value of loss at issue, or variance of the loss at issue random variable for a life insurance policy. So, for fully discrete whole life insurance of $100,000 on a 40-year-old, you're given expenses are $1,000 at issue, $50 at the beginning of each subsequent year. Commissions are 50% of the first year's premium and 10% of each subsequent year's premium. G denotes the level annual gross premium. L sub 0G denotes the gross loss at issue random variable. Mortality follows the standard ultimate life table, and interest is 5% per year. First, write down an expression for L sub 0 super G in terms of G, K40, that is the number of whole years that this 40-year-old will survive. K for Kurtate. I know we don't spell it that way, but that's how we write it down. And interest rate functions. So, expenses, you could view this as expenses being $50 at the beginning of each year plus an additional $950 at issue. Hence, $950 right off the bat, plus $50 each year starting including the first. That's going to be A double dot angle K40 plus 1. The plus 1 being that if you suppose you live, 10 and a half years. Well, then you actually make 11 payments because you're beginning for 11 beginnings of years. All right? Commissions are 50% of the first year's premium and 10% of each subsequent year's premium. We can, again, view that as 10% of each year's premium plus an additional 40% of the first year's premium. Okay, fine. So 0.4G right off the bat, 0.1G A double dot angle K40 plus 1. Fine. And then, of course, when the person ultimately dies, then there's going to be a death benefit. So you would say plus 100,000 times nu to the power of K40 plus 1. The plus 1 being that, if you die 10 and a half years in, that means you die in the 11th year. And because it's fully discrete, right, you don't issue the payment until the end of that 11th year. If the insurance company is paying out at the beginning of the year, that means before you died, which means they somehow had advanced knowledge of whatever killed you, which would be suspicious in the eyes of the law, to say the least. Anyway, then finally, we do subtract out the premiums that the company has actually been collecting. So minus G, A double dot, angle K40 plus 1. And you can do some algebra to combine these, right? You can say that it's going to be G times negative 0.9 K40 plus 1 and such. Right? This combination and simplification, I'm sure you've done loads of times when you've done a lot of the practice multiple choice problems. In fact, even setting something like this up, you've probably done. Right? Obviously, part A1 was not the difficult part of this question. Part B, show the premium calculated using the equivalence principle is 860 to the nearest 10. You should calculate the premium to the nearest 0.1. Again, not... In fact, in hindsight, I'm a little surprised that this is worth 4 points because I feel like this is exactly the sort of thing they would ask you to do on a multiple choice question, which is usually worth 2 points. But anyway, crunching through, you just take the expectation of everything. Expectation had better be 0. So we get that the expectation of this loss random variable 950 is obviously going to be itself. Expectation of A double dot angle K40 plus 1 is just going to be A double dot 40. Right. When you're averaging it, you can just rely on the life table figures. Same as nu to the K40 plus 1, right? When you average that, that's just going to be the average value of a life insurance benefit to a 40-year-old. Right? Shouldn't be anything surprising there. Notice here I combine the 0.1G and the minus g, and just combine them into a minus 0.9g. You look up a double dot 40, you get 18.4578. You look up a 40, you get 0.12106. Algebra happens, and you get g equals 862.3. Okay. Part B. Calculate L sub 0 super g for an individual policy using the premium from Part A2, and assuming that t lies at its median value. So we look back at the table. We notice that L40 was 99,000 and change. Half of that is going to be 49,000 and change. You scroll down, figure out that somewhere between 88 and 89. And so we know that T40 is somewhere between 88 and 89. So assuming that you die somewhere in your 88 years old year, all right. So that means that you're making 49 payments, right? One at the beginning of one around your 40th birthday, the last at your 88th birthday, right? There's one more fence post than there are spaces between them. So you say LG is 950 plus 50 times a double dot angle 49 plus 0.4 times 862.3. Had that multiplication symbol a little more visible there. Minus 0.9 a double dot 49 times 862.3 plus 100,000 big A angle 49. You crunch these numbers for the value of a future benefit being paid 49 years into the future, and for a 49-year annuity, you get 19.077 for the annuity, 0.09156 for the benefit. Algebra happens, and you get L sub 0 g equals negative 33.99. Okay. The company expects to sell 100 identical such policies to individuals with independent future lifetimes. Let L denote the aggregate loss at the time, its aggregate loss at issue on the portfolio of 100 policies. For one easy point, explain why if the company charges the equivalence principal premium, probability that L is positive is approximately 0.5. Detailed calculations are not necessary. Yeah, central limit theorem, right? Well, when you have a large number of identical policies, the result will be approximately bell-shaped. When it's at the when you use the equivalence principle, the average gain is going to be 0, hence equivalence principle. For a normal distribution, half of it's above the mean, half of it's below the mean. Oh, look, 0 is the mean. The probability of being above the mean is 50-50. Okay. Big whopping surprise. You don't exactly need to be an actuary to know that. Now here's where it actually gets interesting and somewhat difficult. Especially difficult if you try to just commit formulas to memory rather than understanding where they come from. Because if you're familiar with derivation of standard deviation of loss at issue for an insurance policy, then this is a routine calculation that you've done before. If you try to commit the formula to memory of standard deviation when you don't have any expenses and everything's in accordance with the equivalence principle, then you will have memorized the wrong formula, attempt to use the wrong formula and get no points, or realize that you can't use the formula you memorized, not have a backup, and get no points. So, chief actuary believes that if the company charges the equivalence principal premium, there is too much risk that the portfolio will not be profitable. I would agree. She proposes setting the gross premium at G equals 900 rather than the 862. Fine. Calculate the probability that the aggregate loss on the portfolio is greater than 0. That is, PL greater than 0, assuming a premium of 900 per policy, and using the normal approximation to the distribution of L. So we need mean and standard deviation, or mean and variance. We're going to use central limit theorem here again. Right? We need the mean loss, the standard deviation of the loss, and then just take a z-score, look up in our z-tables, and that's that. All right, so once again, we have our formula for L sub 0g, 950 plus 0.4 times 900 minus 760 times a double dot angle K40 plus 1. I'll explain where that 760 comes from in a moment. Plus 100,000 nu to the power of K40 plus 1. Where's that 760 coming from? Well, we said that the gross premium was 900. If we remember what the expense rules were, 10% of each year's premium is taken, right? So 10% off of 900 is 810, and an additional 50 is taken at the beginning of each year. 50 from 810 is 760. All right. So we have the gross loss at issue random variable. Fine. Arithmetic happens. 0.4 times 900 is 360. And here's the core of what enables us to actually calculate a variance naturally. Notice we have two random variables here, right? We have this annuity random variable and this death benefit random variable. They are related to each other. The longer the person lives, the greater the annuity random variable is going to be, and the lesser the death benefit random variable is going to be. We can't just take their variances separately and add them. They are not independent. However, we can use a trick to express it all in terms of just one random variable, this new random variable, the death benefit random variable. See, as I'm sure you remember, the annuity random variable and the death benefit random variable are related from by the formula annuity equals 1 minus benefit divided by d. It turns out that's not just true when you're taking the average. That is true for each specific policy, no matter what the random numbers happen to be. All right? And I'll go more into that in the derivation video that I said previously I owe you. It will hopefully be up by the end of the week. Probably by the time you're viewing this, it'll already be up. Anyway, so we do that algebraic manipulation. We say that this a double dot angle K40 plus 1 equals 1 minus nu to the K40 plus 1 divided by d, that's 1 minus 1 over 1.05. More algebra happens. We get 950 plus 360 minus 760 over 1 minus 1.05 plus 760 over 1 minus 1.05 times nu to the K40 plus 1 plus 100,000 times nu to the K40 plus 1. All right. So for taking the expected value, I didn't even have a line of algebra for that. Perhaps I should have, but you take the average value of this. This right here is going to be a constant, so its average is just equal to the constant that it is. And then you look up A40 in the table, right? Well, we said that was 0.12106. And multiply by these figures here. That gets us the average. And we crunch the numbers together. We get that the mean loss at issue for one policy is negative 611.93. It makes sense that this would be negative because you increase the premium, so you're bringing in more than you're losing now. Variance. Notice again, this thing here is a constant. Constants have zero variance. We can just ignore it. And we can factor out this nu to the K40 plus 1. We can just add these two. And when I multiply a random variable by a deterministic constant, the variance just gets multiplied by the square of that deterministic constant. Hopefully you remember that from exam P. To get the variance of a $1 death benefit, you use the all too familiar formula, a pre-super 2 x minus ax squared. So we look those up in the table. For 40-year-olds, a pre-super 2x is 0.02347. Ax is 0.12106. Yeah, no big surprise there. Algebra happens, we get, then arithmetic happens, we get that the standard deviation for one policy is 10,887. So mean for one policy is negative 611.93. Standard deviation for one policy is 10,887. Since we have 100 of them, the mean obviously scales with the number of policies. So our 611.93 becomes negative 61,193. Standard deviation for the aggregate loss, sorry, this should be mean of the aggregate, not mean for one, my mistake. Standard deviation of the aggregate should be multiplied by 10, right, the square root of the number of policies. Hopefully you remember that. So standard deviation of the aggregate loss is 108,870. Z-value is just mean divided by standard deviation, and so negative 0.562, and the corresponding probability is going to be 28.7%. I guess since we want a probability of it being higher, I guess you'd have the standard deviation, you'd have the z-score actually be positive 0.562. You obviously know it's going to be less than 50-50, so use the table whichever way it's going to get you the 28.7 and not the 71.3%. Yeah, so that's all there is to this problem. Again, if you try to just commit the formula to memory, this problem was intended to trip you up. This is part of why I stress try to avoid just committing formulas to memory. Try to remember where most of them come from. These questions will attempt to trip you up. And so hopefully you can remember this trick for whenever they ask you to essentially rederive or do anything involving standard deviation of a life insurance policy when you have expenses and you don't use the equivalence principle. And with that, if you like the way I explain things and wanted to arrange private lessons, check the link in the description. And until next time, this is Dr. Nighttime wishing you a good night. Hi, Dr. Nighttime again. Just real quick, I realized one part of the problem that I forgot to do on the first recording of this. Just that last one pointer. Company will hold full preliminary term reserve should this insurance. State whether the full preliminary term reserve at duration 5 will be higher, lower, or the same. If the gross premium is 900 instead of the equivalence principal premium, justify your answer. You do not need to calculate the reserve. Yeah, so the trick here is to remember that the reserve is always the prospective reserve. You can only do retrospective reserve when it's with equivalence principle, but the important thing is the reserve just asks how much money do you need to have in the bank in order to cover all the terms of the policy. And so here, if you increase the premium, you're getting more money later. If everything else is the same, that means you don't need as much in the bank. So the reserve will be lower. That's all there is to it. All right, just thought I'd add that in as sort of the epilogue. All right, bye.